Hey guys, this is skill 8.7, and in this unit we're going to start applying some of those properties of parallelograms. And I kind of split this lesson into two parts. So 8.7 and 8.8 are both using the properties of parallelograms. I just didn't want the videos or the assignments to get too long. So here we go with 8.7. We are going to need to remember all of the things from the last lesson. Well, not all of the things actually. We're not going to be dealing with any diagonals for this one. So for this lesson, we need to remember that the sides of a parallelogram are parallel to the sides across from one another. They're also congruent. So top and bottom is congruent, and then left and right is congruent. And then we also need to remember that opposite angles are congruent. So those guys and those guys. And then we need to remember that all of those adjacent sets are supplementary. So they're always equal to 180 degrees. So I'm not going to do all of them. I'll just do the one right there. So I think that will be fine. All right, so in example 1, take the time to draw it. It's going to take a little bit of time to draw it. And we can see that it's a parallelogram. They gave us the arrows, so we know that it's a parallelogram, so we know that it has these special properties, so we can use that information to solve for x and y. Okay, so if we first look at where x is located in this lower left-hand angle. So what do we know about angles? Well, we know that the ones across from each other are equal to one another. So that one's not so bad. 2x is equal to 50. Divide by 2. So x has to be 25. And then if we go and find where y is, well, it looks like y is on the left-hand side, and that side is congruent, or sorry, on the right-hand side, that is congruent to 18 on the left-hand side. So that one's also not so bad. Y plus 3 has to be equal to 18. So y is equal to 15. So really just a pretty basic one that just reminds us that our sides are congruent to the sides across from them, and the angles are also congruent to the angles across from them. Now, could we go find some more information here? Sure. We could figure out the measure of angle M if we wanted to. It would be 130 degrees. Now, they didn't ask us to do that, but I think it might just be worth touching on that real briefly, because those adjacent angles would need to be supplementary. Now, as far as like side KL goes and side JM goes, I don't think we quite have enough information there to solve for those, so we'll move on to example 2. All right, in example 2, we're asked to solve for not just x and y, but this time x and y and z. So it doesn't probably really matter where you start on this one. I guess I'm actually going to start by showing you that this is a parallelogram. That's kind of a bad problem. If they don't tell us it's a parallelogram, there's not a lot we can do. So I'll add the parallel symbols in. And I guess I'll probably just start with angle x. So I can see that angle x is next to the angle that we know is 102 degrees. So I know that those should add up to 180 degrees. So we could just do x plus 102 is equal to 180. And subtract 102. And then x would be 78. Perfect. So that one's done. And then y, well, y is across from 102 degrees. So that one's pretty nice. Those angles have to be congruent to one another. So we can just say that y is equal to 102 degrees. Okay, there's other ways to do it. We could have done the whole adjacent angle thing with angle x, but probably easier to just realize that you have it right in front of you there. And then the last one, we have the left side again and the right side, which we know have to be congruent. So we can just say that 13 is equal to 3x minus 2. Solve that one. Getting lots of equation solving in this unit. And that was, oh shoot, that was a z the whole time. Let's just back up and fix that real quick, sorry. Z. So 5 is equal to z. Alrighty, that is it for that one. So hopefully, as long as your algebra is going okay, shouldn't be too bad. But let me know if you're running into any issues on that lesson.